Okay, geometry fans, our lesson for today is Unit 1-4, Exploring Angles and Angle Relationships. So the objectives today, after this lesson, students should be able to 1. Identify angles and parts of angles, use the angle addition postulate to find the measures of angles, classify angles as acute, obtuse, right, and straight, and identify and use angles and the bisectors of angles. Okay, so quite a few things we're going to do, a lot of vocabulary. Before we start, let me tell you your joke of the day. Why did the computer go to the doctor? And the answer, because it had a virus. All right, so we're going to start with the definition of an angle, and the first thing we'll define is the word ray, which is a segment extended indefinitely in one direction. Okay, so it has one endpoint. So we've talked about how a line goes in two directions, and then a segment just contains the endpoints and then what's between them. So what a ray does, it's a combination of both. We have one endpoint, and then it extends indefinitely. It keeps going in the other direction. So the way we name this, we would say LM, and we would draw a symbol for a ray, which is just one arrow. Now it is important that I start with L because that's the end point. If I write ML, if I write it like that, then what I'm saying is that the end point is M and it goes through L and then it keeps going, which is wrong because in this picture it doesn't go this way through L. It starts at L, it goes through M. Okay, so this is important. The order is now important. So in this, they give you 3 points. Now you only use 2 of them to name a ray. The end point is R, so we have to start with R. And if we say ray RQ, the arrow goes through Q and it keeps going, so that would be okay. You could also say ray RP, because if you go from R through P, you also will hit Q, and then you'll keep going. So either of these is correct. We couldn't say QP because if we start with Q, we would be missing all these points right here. And you only use 2 points, so you won't say RQP, okay? Ray RQ, ray RP. Now, what an angle is 2 non-collinear rays that share a common endpoint, and that's what we call a vertex. So the vertex, we have ray BA and ray BC. So we have ray BA and ray BC. Notice that they share the same endpoint right here. That's point B. That is the vertex. Now this is really important that we can identify this because when we name an angle, the vertex is the most important point. So there's a couple ways you can do this. You could use 3 letters, 3 points, and we could say here's angle, so angle symbol, A, B, C. So angle ABC would contain both rays. You could say angle CBA. You could just say angle B. So you could just use the vertex, and that's all you would need. Angle B would be this. If there's a number inside, sometimes we'll use a number to represent an angle. That would be angle 2 in this case. That's not the measurement. It's not 2 degrees because there's no degree symbol there. So that's actually the name of the angle, angle 2. If you use 3 letters, the key is that the middle letter has to be the vertex. So B, the vertex, must be in the middle. Now the other thing that we'll draw here on the side, when you have an angle, there are 3 places that you could put a point. You could be in the interior, which is inside the angle. That's between the 2 rays. You could be in the exterior, which is like the outside. Exterior is the outside, so that would be here. The third place you could be is on the angle. So you could be in the interior, you could be in the exterior, outside, or you could be on the angle. Okay, so again, we're going to be using a lot of these words, interior, exterior, and we need to know what they mean. All right, so example number 1, name all the angles in the following diagram. Well, here's your picture. One thing I like to do is I like to trace these out. So we have this angle in red. The vertex is W, so angle RWX is good. RWX traces the whole angle. If you wanted to say angle XWR, that's also good. We have another angle here, which I'll put in blue, angle XWM, or angle MWX. So again, W is the vertex. So we have two small angles. So we have angle RWX here, and you'll see we'll draw arcs sometimes. Angle XWM, I'll draw two arcs. There's actually a third angle in this picture. There's the big one, angle RWM, or angle MWR. It would be a mistake if I said angle RXW. RXW would not be this angle. RXW would be this. So again, the vertex W has to be in the middle. Now you might be asking, why can't we just say angle W? Well, the problem is, if you say angle W, which one are you talking about? Is it this one, or this one? So if you have angles that are next to each other, we have to use 3 letters. And we would say angle RWX and angle XWM, okay, on the side here, angle RWX, angle XWM are adjacent. You'll see this word again in the next set of notes, but adjacent means next to. So those two angles, they both have the same ray, and they both have the same endpoint, but anything inside RWX is not inside XWM. So they're next to each other, but they don't overlap. Okay, so those two small angles are adjacent to each other. All right, so some more vocabulary, classifying angles. Classify means to give a name. Classify means to name. Acute means less than 90 degrees. An acute angle is less than 90. So as an example, there's 45 degrees. Notice I put a degree symbol there. That's telling me the measure of the angle. So acute would be less than 90. And if we call this angle, let's say P, we would say M, angle P, equals 45 degrees. That M stands for measure. So the measure of angle P is equal to 45 degrees. Measure of angle P. Now, in some books, they won't put the M, they'll just say angle P equals 45 degrees. That's also okay. So acute, less than 90. Obtuse is between 90 degrees and 180. Now, most of the time we think of that as greater than 90. Obtuse would be something like this. So let's say that's 110 degrees right there. That's an obtuse angle. The reason we have to say it's less than 180 is that 180 is a special case. 180 would not be obtuse. A right angle means equal to 90. We don't usually write the number 90. What we do is we put a box. So if you see that box, that means that this is a 90-degree angle, which means this is a right angle. Now, something to be aware of, that when you are in geometry, sometimes the picture is not accurate. If you saw this picture, I know that that looks like it's less than 90, but if you see this box, this is a right angle. If I call that A, that point, the measure of angle A is equal to 90. So you have to go by what they give you in the picture, the way it's labeled. It doesn't look like 90, but according to this picture it is. Okay, and then the last one, a straight angle is equal to 180 degrees. A straight angle is basically a straight line. Okay, so if I put some points on here, ABC, the measure of angle ABC is equal to 180. Now that might seem kind of weird. When are we actually going to use that? Well, this actually comes up in a lot of places. Not necessarily like this, but you'll see where this relationship that a straight line is 180, that's really important. The reason it's 180 is if you think of a circle is 360, but the diameter would split the circle into two equal halves. So if the circle's 360, then half is 180. Okay? So that's the reason for that. Let's flip it on the back here. And we'll talk about one more thing in the first part of these notes. Angle addition postulate. Now, we already talked about segment addition postulate. If you add the parts, you get the whole thing. Angle addition is the same idea. So the definition here, if P, the point, is in the interior, inside, of angle RST, then the measure of angle RST is equal to the sum of the measures of angle RSP and angle PST. Now that's confusing, so let's draw a picture here and see if we can figure this out. So if P is in the interior of angle RST, now angle RST, since S is the middle letter, that's your vertex. The R goes on one of the rays, the T goes on the other. It doesn't matter which one, that's your choice. Now P is in the inside, so let's put a point inside, there's P, and we will connect that. So if P is in the interior of angle RST, then the measure of angle RST is equal to the sum, so that means we're going to add, of the measures of angle RSP and angle PST. Let's say that angle RSP is 40 degrees and angle PST is 30 degrees. What they're saying is that the big angle, RST, the measure of angle RST equals, you can add the two small ones, the measure of angle RSP plus the measure of angle PST. You'll notice I keep tracing. That's so that when I write the angle, I write it correctly. Okay? PST is that whole thing. So that would be 40 plus 30. So the measure of angle RST is 70 degrees. So the idea is that if you add the two parts, you have to get the whole thing. That's the angle addition postulate. And that is the end of part 1.